So in this video we're going to be doing an intro to solving equations with variables on both sides. Now we already know from our notes from last week that an equation is like a balance scale, and we already know that we need to isolate the variable on one side. The goal is to get x by itself on one side. And I even gave you the steps to solving any equation. Last week I gave this to you. So step one is to simplify both sides of the equation. That means distributive property and combining like terms. Step two is to isolate the variable on one side of the equation to get x by itself. So all of last week we were just doing step two because I gave you nothing but simplified equations. And last week we only had x's on one side of the equal sign. This week we're going to be having x's on both sides of the equal sign. So let's move on to a visual example. Check it out. So we have a little picture here of a toy scale, but it'll do. And we're going to call this red cylinder, we're going to call it x. And let's also call these little ones just the value of 1. So let's create an equation here. Let me put a couple of x's. Let me put 1, 2, 3 x's on this side, which is going to be completely off balance right now. And let me put some stuff on the other side. So I'm going to take one of these guys, put it up here, and then, okay, well, how about that? We have 3 x's on this side, and then we have 3 of these single unit, and then we have 1 x over here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those single unit ones. So let's solve this equation that has x on both sides. Well, remember, an equation is like a scale, as you can see right here. And whatever you do to one side, you can do to another side. So I could start removing things. So let's say I wanted to remove 3 of these guys, all right? Let's say I wanted to remove all 3 of these guys, okay? So let's do this. Now, keep in mind, right now, there is perfect equality, right? There's an equal sign between the left side and the right side. As you can see, they're balanced. Now, what I'm about to do is I'm going to remove 3 of them. So 1, 2, 3. Now it's no longer balanced. This is light unless I subtract 3 on this side. So let me remove 3 on this side as well. 1, 2, 3. So now it's still balanced, right? As long as what you do to one side, you do to the other side, you're good. So what about the x's? Well, I have x here and x over here. I don't want x's on both sides. Remember, the goal of solving an equation is to get x by itself on one side. So I don't want x's on both sides of the equal sign. I only want it on one side. So let's get rid of this x over here. But remember, what you do to one side, you must do to the other. So I'm going to remove it. As long as I remove it, then it's still balanced. Okay, so we do have 2 of these x's. So at this point, all I need to do is realize how much each one of these x's is worth. So to do that, let's focus in on what we have over here. What do we really have over here? We have, let me move this a little. We have 1, 2, 3, 4, 5, 6. Now there's 2 x's and there's 6 single unit cubes, or whatever these are, cylinders right here. Since there's 2 x's, imagine I could actually make this into 2 groups, 2 equal groups. So it makes total sense that this one x right here is worth 3, and the other x is exactly worth the same amount, 3. So what I'm going to do here is simply divide by 2. Now, I know that looks weird because we said that they're worth 3, but what actually happened is that we took the left side, which is really x and x, and what did we do? We divided it into 2 because there's 2 x's. We separated them. And over here, what did we do? We took the group of 6 and we divided it into 2 to make a group of 3 and 3. So we really did divide by 2 right there on both sides. And now I could actually remove the x from this side and remove the 3 from this side, and I get my answer, x equals 3. So this is just an intro, just to get you to better understand equations with variables on both sides. The only difference between what we've been doing last week and this week is that last week we had an x on this side, and this week we have x's on both sides, right? So again, it boils down to what's the goal of solving an equation? To get x by itself on one side. So if you ever do have two x's, one on one side, one on the other, you have to get rid of some of those x's. How do you get rid of something? By doing the opposite, right? By removing it. And what you do to one side, you do to the other side. Let's move on. So what I want to do right now is take this exact visual equation that we already solved, and let's solve it algebraically. So I'm going to write down x plus x plus x plus 1, 2, 3 ones, and I'm going to write it down algebraically. Here it is. Check it out. Now, it's kind of ridiculous to write it this way. Well, I'm sorry. It's kind of ridiculous to write it this way because we already know that you could combine the 3x's, or yeah, so it'd be 3x instead of that. But I wrote it exactly like that so you could use your notes. Let's go back to our notes over here. Our notes, step 1 to solving any equation. It says simplify both sides. Now, when you think simplify, you need to think two things. What are those two things? Distributive property and combining like terms. So obviously you need parentheses to have distributive property. And there are no parentheses right there, but you do have combining like terms. You could combine all the terms that are alike. And you do this one side at a time. Okay, so you look at your left side, and what could you combine on the left side? You could combine all the x's. X plus x is a total of 3 x's. And of course, the 1 plus 1 plus 1, that's a total of 3. And the equal sign simply comes down. And on the right side, you have that single x. You can't combine it with anything. But the 1 plus 1 plus 1 plus 1 plus 1 9 times, that ends up giving you plus 9. So we did step 1, which is simplify each side of the equation one side at a time. And now we can move on to step 2. Step 2 says to isolate the variable on one side of the equation, to get x by itself. Remember, what you do to one side, you must do to the other. So we go back to our goal of getting x by itself on one side. Problem here is you have x's on both sides of the equation, so let's get rid of this x right here. Now, if I had the 3x over here and 1x over here, I had to get rid of the 1x, and that way I could have x's left over on the right side. So I have 3 here and 1 there, so which one's easier to get rid of? The 1. So let's get rid of that 1x by subtracting, taking it away, right? So x take away x is 0 x's, it cancels out. What you do to one side, you must do to the other. 3 x's take away 1x, that will be 2 x's left over. Bring down the plus 3, bring down the equal sign, bring down the positive 9. And now we have the two-step equations that we've been doing all of last week. We have x on the left side. We need to get it by itself. It's not by itself. There's a 2 right there and there's a 3 right there. We need to get rid of this 3 first by doing the opposite. How do you get rid of something? You do the opposite, right? So what's the opposite of plus 3? Minus 3. And what you do to one side, you do to the other side to maintain the balance. What do I have left? I have a 2x left on the left side of the equal sign, and on the right side I have 9 take away 3, which is 6. For my final step, I need to recognize that I really do have 2 times x right there equals 6. So in order to get rid of the multiplication of 2, I do the opposite of multiplying by 2, which is dividing by 2. And what you do to one side, you must do to the other to maintain the balance. As you can see, 2 divided by 2 is 1, so you simply have x on the left side. Let me move this up a bit. I have x on the left side, the equal sign, and 3 on the right side. My answer is x equals 3. So let's jump to the back side of our notes today. And on the back side, we really have a multi-step equation that has variables on both sides and that requires simplifying. Okay, so as you can see right here, again, our front side notes say this, that you have 2 steps. Step 1, simplify both sides of the equation. And you know what? You should also say, do one side at a time. Okay, you want to do one side at a time. And what do I mean by simplify? It's distributive property and combining like terms. So do one side at a time. So as you can see right here on this example that I gave you, here's your equal sign, here's the left side, here's the right side. And on this one, we don't have a variable on the right side, but we do have some simplifying. On the left side, we need to simplify. Let's ignore the right side for a little while. Let's just focus on the left side. On the left side, we have distributive property, and we also have x's and x's. So we also have combining like terms. So of course we're going to distribute first. So 2 times 3 is 6, and that's with an x. 2 times negative 5 is negative 10. Then I bring down the minus 4x. And then I could combine the 6x with the negative 4x. Whenever I combine like terms, I like to use like circles or underline, whatever I'm combining, and include the sign that's in front. So when you combine the 6x with the minus 4x, you will get positive 2x. It's like saying I have $6, I take away $4, I owe somebody $4, I'm only going to have $2 left. The minus 10 comes down, and then I rewrite everything. The equal sign keeps coming down, and right here on this side, I do change the minus minus on the right side to plus plus. Now notice, there's nothing else to do on the left side. I've already distributed up here. I've already combined like terms right here. So there's nothing else to do. So the left side is simplified. So I've already simplified the left side. Now I'm going to look at the right side and see if I could simplify. And of course, when you have a minus, minus right next to each other, you change them to plus plus. And then I could actually combine negative 3 plus 5. If I owe $3 and I have $5, I could pay them off. I'll have $2 left over. Now this is what we call our simplified equation. It is completely simplified. There is no more distributive property, no more combining like terms. The left side simplified, the right side simplified. It's a simplified equation. Once it's simplified, now we could worry about solving, which means get x by itself on one side. So of course, it's rewritten down here. Now let's actually isolate that variable together here. We're going to go plus 10, plus 10. We will have the 2x that comes down, the equal sign that comes down, and 2 plus 10 is 12. Final step is to recognize that it really says 2 times x, and to get rid of the multiplication of 2, you do the opposite of multiplying by 2, which is dividing by 2. And of course, what you do to one side, you do to the other. So x equals 6. There's our answer. Now, if we read along with our notes right here, it says many times we'll have equations with variables on both sides. So it's exactly what I was talking about on the previous example, where you have x not only on the left side of the equal sign, but you also have x on the right side. So this one's already simplified. There's no more distributive property on the left side. So if you look at the left side, there's no distributive property, there's no combining like terms, it is simplified. If you look at the right side, it's just the letter x. There's no distributive property, there's no combining like terms, it is simplified. So this is a simplified equation. Now that you know it's simplified, now let's worry about step 2, getting x by itself, the goal to get x by itself on one side. Now the problem is you have x's on both sides, and there's many roads to the same place. So you need to ask yourself, do I want to get rid of this x and move it over here? Or do I want to get rid of this 2x and move it over there? As long as you get x by itself on one side, it could be to the left or it could be to the right, whatever you prefer, right? Most of the time I move x's this way. So right here, just to be different, let me move the x's to the other side. So I will have a negative 2x and a negative 2x. And of course, 2x minus 2x is 0. Let me bring down what I have left. I have a negative 10. Let me do it in black. Negative 10. The equal sign comes down. And if I think about this, x take away 2x in my head. If I have 1 and I owe 2, I'm still going to owe one of those x's. So that's my new simplified equation. And I want to get x by itself. I don't want a negative 1x right in front of there. I don't want this negative 1, which is really negative 1 times x. So to get rid of multiplication, again, you're going to use division. And you will have x equaling negative 10 divided by negative 1. That's positive 10. So let's have you guys try. Now, as you can see, on these two, these equations are already simplified. If you look at the left side, there's no distributive property. Look at the right side, there's no distributive property or combining like terms. So these two are already simplified. You're still thinking about step 2, the goal, right? Step one is to simplify both sides, but they're already simplified. So you're going to focus in on the goal to get x by itself on one side. So on number 1, you don't want the m's on both sides. So let's get rid of the m's. Now I'm going to this time move the minus 6m. I want to get rid of the minus 6m and make it be, move to the left side. To get rid of the minus 6m, I do the opposite, plus 6m. And what I do to one side, I do to the other side, plus 6m. And of course, I'm not going to put it underneath the 1 because you can't add 6m plus 1. You could only combine it with the other m. So right here, 6m take away m, that is positive 5m. If you owe $1 and you have $6, you could pay them off, you'll still have 5. That is a positive 5. And the 1 comes down in front, the equal sign comes down, the 6 comes down. Now we have our equations that we're used to with the variable on one side. So let's get rid of the 1, which do to one side, do to the other side. Let's rewrite what we have left. 5m equals 5. That is because right here they canceled out and 6 take away 1 is 5. Now for my final step, I recognize that I'm multiplying 5 times m. So to get rid of that, I divide by 5. And of course, I'll have my final answer, m equals 1. Let's move on to the next one. So on this one, again, we want x by itself. Again, they're already simplified. You want x by itself on one side. So you have x's on both sides. You don't want that. Let's get rid of one of them. Again, I'm going to get rid of the minus 3x. That way I could end up with positive x's. I could have gotten rid of the 5x by subtracting 5x, but I'm going to move the x's to the left side. So if I add 3x on the right side, I need to add 3x on the left side to maintain the balance. So once again, the negative 3x and the positive 3x cancel out. Let me bring down my equal sign, bring down the 13. Over here, 5 plus 3, that is a total of 8 with x's. And let me bring down the minus 3. There's my new equation. Now I only have x on one side. Let's get that x by itself on that one side. So let's get rid of the minus 3. What you do to one side, you do to the other. Your new equation is 8x equals 16. I need to get rid of the 8 that's being multiplied by x. So I'm going to divide by 8. Divide by 8. My answer is x equals 2. Now these next two problems is where we actually have to simplify first. All right, this is again step 1 on solving any equation. From the front side, step 1, simplify both sides of the equation. Of course, you want to do one side at a time. And what does it mean to simplify? It means two things: distributive property and combining like terms. You might have both to do, you might only have one of those to do. So let's take a look at number 3. As you can see, the left side has distributive property and the right side. So let's just focus in. Let's kind of ignore one of these sides. Let's just block that out for a little bit. Let's distribute the left side first. Negative 3 times x, that's negative 3x. Negative 3 times 5, that's negative 15. That's what we call a simplified left side. There's nothing else to do. I cannot combine like terms. That's it. That's all I could do. So how about the right side? So in other words, let me just move this over, cover that up. And on the right side, is there anything to do there? Is there any distributive property or combining like terms? Yeah, there's distributive property. So let's distribute. 3 times x, that's 3x. 3 times negative 1, that's negative 3. And of course, there's an equal sign between the two sides. So ladies and gentlemen, that is our new simplified equation. So that was step 1. Do any distributive property or any combining like terms. That's what we call simplifying. This is our simplified equation, and now we could worry about getting x by itself on one side. So I do have x's right here and here. Let's get rid of one of them. I'm going to get rid of the minus 3x this time. I'm going to move it to the other side by adding 3x. And what I do to one side, I do to the other side, add 3x. So that will cancel out. My new equation is negative 15. The equal sign comes down. Let me do this in black. Negative 15. The equal sign comes down. 3 plus 3 is 6 x's, and then minus 3. So I do have x all by itself on one side. Again, you could get your x's to the left side or to the right side. The goal is to get x by itself on one side. It doesn't matter which side you choose. So let me continue and get x by itself on the right side of the equal sign over here. So I'm going to get rid of the minus 3, the bum at the corner. So I'm going to go plus 3. And what I do to one side, I do to the other, plus 3. Negative 15 plus 3. If you owe somebody 15 and you only have $3, you could pay them, but you're still going to owe them 12. So 12 equals 6x. Final step here will be to divide both sides by 6. I'm sorry, I'm running out of space here. Divide by 6, divided by 6. So your answer, on the left side, you're going to have a negative 2. On the right side, you're going to have an x. So the answer is negative 2 equals x. But of course, you want to write it with the other way around, x first. So x equals negative 2. That's your answer for number 3. Number 4 is the last one we're doing. And some of us might get confused with this fraction, but we could still distribute the fraction. It's as easy as this. You're going to be multiplying by 1/2. All right. Now, you could show your work if you want to, or you could do it in your head. You could say 1/2 times 6 is 3. Or if you want to, you could say 1/2 times 6, show your work. You could put the 6 over a 1, and you could multiply 1 times 6 is 6, 2 times 1 is 2. So you're going to have a 6 on top over a 2 on the bottom, and 6 divided by 2, that is 3. Okay, so you don't have to show this work, but you could. But you also have to distribute the 1/2 times that y, or times negative y if you want to include it. So if you did multiply 1/2 times y, you could put the y over 1 if you wanted to, and multiply the top with the top and the bottom with the bottom, and you will end up with y over 2. And that you really can't do anything about, so let's just bring down the y over 2 right next to the 3, and let's bring down that minus sign that's between them. So I really have 3 minus y divided by 2 equaling y. Now the problem here is that we have fractions, right? We do have variables on both sides, but we also have fractions, right? So we could get rid of fractions by simply multiplying everything by 2. Now it wouldn't make sense for me to move the 3y over, or the 3 over, because if you subtract 3, you can't really subtract it from y, so I might as well get rid of the fraction first. I'm going to multiply everything by 2. This times 2, this times 2, this times 2. I'm going to write my new equation up here. That will be a 6 minus, the 2's canceled out, right? These guys canceled out, so you're going to have a minus y left over, equaling 2y, because y times 2 is 2y. So again, we want to solve for y. We have a y here and a y there. Let's get y by itself on one side. So I am going to get rid of the minus y by going plus y. And what I do to one side, I do to the other, plus y. So I will have a 6 left over, an equal sign because those guys canceled out, an equal sign left over, and the 2y plus y, that's a total of 3y's. I must recognize then that it's really 3 times y, so I get rid of that multiplication of 3 by dividing both sides by 3. Final answer is 2 equals y, or y equals 2. Now there's many different ways of doing this problem. There's probably shorter ways. I might explain that on the next video, but this video is getting way too long. We're going to stop right here, and we'll pick up on the next video, on the next section here.